Hey everyone, and welcome. Today, we're going to pull back the curtain on one of the most important but kind of invisible technologies that basically runs our digital world: REST APIs. They're the secret language that lets all your favorite apps talk to each other. So, how does that actually work?
You know that feeling? You open up a food app on your phone, you're starving, and bam! The entire menu from a restaurant halfway across town just appears. How in the world does your app get all that info so fast? Well, that little bit of magic is a REST API working its tail off behind the scenes.
So what exactly is it? Well, at its heart, a REST API is just a set of rules for how different programs can chat with each other over the internet. And honestly, the best way to think about it is like a waiter at a restaurant. Your app is the client. You're the customer giving an order. The waiter is the API. They take your order to the kitchen, which is the server. The kitchen cooks up what you asked for, and the waiter brings it right back to your table. Simple as that.
Okay, to really get a handle on REST, we need to talk about two foundational principles. These aren't just good ideas. They're the core rules that make this whole system work so well.
The first golden rule is a super strict separation between the client and the server. So the client, or the front end, that's what you actually see and click on, like a website built with React. All it cares about is making things look pretty. Then you have the server, or the back end. That's where all the data, the business logic, and the database live. Now, because they're totally separate, a team of developers can completely redesign the website without ever touching the server. And here's the really cool part. A company can use the exact same backend to run its website, its iPhone app, and its Android app. That's a huge deal.
The second golden rule is statelessness, and this one is absolutely crucial. It means the server has total amnesia. It forgets everything about you the second it answers your request. So every single time your app asks for something, it has to include all the information the server needs to do its job. It's like going into a secure building. You have to swipe your ID card every single time you walk through the door, even if you just did it 10 seconds ago. The server never keeps track of who you are between requests.
Okay, so if the client and server are separate and the server is totally forgetful, how do they have a useful conversation? Well, REST gives them a standard language to use, and it's all built on two simple ideas: actions, which are basically the verbs, and addresses, which are the nouns.
The actions are called HTTP methods, and they just tell the server what you want to do. The four most common ones line up perfectly with this acronym you'll see everywhere: CRUD. For create, you use post. To read data, you use get. For update, you use put. And to delete something, you guessed it, you use delete. This makes every request's purpose totally clear.
And the addresses? We call those endpoints. Really, an endpoint is just a URL that points to a specific thing you want to work with. So if you want to mess with user data, you'd send your request to an endpoint like api.example.com/users. It's the exact address the waiter knows to go to.
So now let's put it all together and look at what a single conversation actually looks like. Every interaction, and I mean every single one, is split into two parts: the request and the response.
First, the client sends a request. This little package is made up of a few key things. You've got the method, like get, and the URL, our endpoint. It also includes headers, which are kind of like little sticky notes with extra info, like an authentication token. That's our digital ID badge. And if you're creating or updating something, you'll have a body which holds the actual data, usually in a super common format called JSON.
Then, after the server does its thing, it sends back a response, and this also has a few key parts. The most important one is the status code. It's a quick signal telling you if everything worked. It also has the data you asked for, again, probably in that same JSON format, and its own set of headers with some extra info.
These status codes are like the server's instant feedback. You don't need to memorize all of them, but you are going to see these four all the time. A 200 just means, yep, everything's good. A 201 is even better. It means it worked and I made a new thing for you. On the other hand, a 404 is the classic, oops, I can't find that address. And a 500 basically means the server is saying, it's not you, it's me, something went wrong on my end.
All right, we've got the rules, the language, and the structure, so let's put this all together and see how this whole thing plays out in a real-world example step by step. This is where it all clicks into place.
Okay, imagine you're in an app and you tap a Show Profile button. That one tap instantly tells the client to build and send a GET request to an endpoint for a specific user, maybe user/123. The server on the other side catches that request, dives into its database, and finds user number 123. It then wraps up all that user's info into some JSON, slaps a 200 OK status code on it, and sends it right back. Finally, your app gets that data and boom, updates the screen to show you the profile. And that entire round trip can happen in less than a second.
So, why this particular system? Why has REST become so unbelievably dominant? What's the big payoff that makes pretty much every developer on the planet choose it for their APIs?
Well, there are 4 huge reasons. First, it's just plain simple. It's built on HTTP, the very thing that's been running the web for decades. Second, it's language agnostic. A server written in Python couldn't care less that it's talking to an app written in React or Swift. Third, because it's stateless, it's incredibly easy to scale up to handle tons of traffic. And finally, it's just really lightweight and fast.
And the proof is literally all around you. Every single time you log into a social media app, browse products on an e-commerce site, or use a payment system online, you are interacting with dozens of REST APIs. They really are the backbone of our modern, connected internet.
For a long time, REST has been the undisputed king. And for good reason. It's simple and it's incredibly powerful. But, as their apps get more and more complex, new challenges pop up. And this leads to a pretty fascinating question. What comes next? You're starting to see technologies like GraphQL emerge to solve different kinds of problems, which makes the whole world of APIs a really exciting space to keep an eye on. Thanks for joining me for this explainer.